In this video, we're going to talk about how to integrate improper integrals with infinite discontinuities. So we have a few types and they're in this box at the top of the screen. So the first type is if f of x is discontinuous at the upper bound of the integral. So for this one, it would be discontinuous at b. For that, we would have a limit as t approaches b from the left. And now our bounds are a and t for our integral. Second type is your f of x is discontinuous at the lower bound. So here we're saying it's some a. For that, we would take the limit as t approaches a from the right, and we would make t the lower bound of our integral. The third option is that f of x is continuous at c, and c is somewhere between a and b, where a and b are the bounds of your integral. So for that, you would start by splitting your integral into two separate integrals. You want to separate at c, which is where your function is discontinuous. And then you have types 1 and 2 at the end as the next step. So we're going to do a couple of examples. Let's start with our number 1. So I have 1 over x squared. Notice that 1 over x squared is discontinuous at x equals 0. So here we're discontinuous at our upper bound. So my first step is I'm going to say, let's take the limit. Now technically you can use any letter you want. So I'm going to say b approaches 0 from the left, from -1 to b, 1 over x squared dx. From here, we are going to evaluate our integral. So I'm going to rewrite it one more time as x to the -2, just makes the integrating a little bit easier. So I'm going to write out my limit again. We'll evaluate the limit after we evaluate the integral. So I'm going to increase my exponent by 1, multiply by the reciprocal out front, and I'm evaluating from -1 to b. So I'm going to plug in those bounds. I'm going to have -1 over b minus -1 over -1. Okay, from here, let's make this a little bit nicer. Well, I guess it doesn't matter. So let's plug in the 0 or evaluate the limit as b approaches 0 from the left. I want you to notice that we should have 1 over x memorized, the graph. This right here is -1 over x, so that graph reflected over the x-axis looks like this. So this is the graph of -1 over x. And so if my b or my x is approaching 0 from the left, notice we're going to be going up to positive infinity. So this goes up to positive infinity. So that is going to be our limit. So we would actually say that this integral diverges. Let's do one more example. For this one, first thing, keep in mind this is 1 over x minus 1 to the 2/3. I want you to notice that this is discontinuous at x equals 1. So this is like that third type in the box. We want to start by splitting this into two separate integrals, and we're going to split it at that 1. And then we're going to set up our limits. So I'm going to say b approaches 1 from the left, 0 to b. I'm going to say a approaches 1 from the right, from a to 3. We're going to evaluate the integrals and then do the limits after that. You would think about u sub for these. U would be x minus 1. Notice du equals dx, so we don't really need to worry about anything changing or putting in a constant or anything like that. So we're just going to say this is x minus 1. Increase negative 2/3 by 1, we get 1/3. Multiply by a 3 out front. We're evaluating from 0 to b. For our second integral, we're actually going to get the same thing, so I'm just going to copy it. But now we're evaluating from a to 3. Let's plug in those bounds. We're going to have b minus 1 to the 1/3 minus 0 minus 1 to the 1/3. And then we're going to have 3 on the outside again. 3 minus 1 to the 1/3, so that's 2 to the 1/3, minus a minus 1 to the 1/3. Notice that when you evaluate the limits, here we're approaching 1 from the left. Notice that both of these go to 0. This one we're approaching 1 from the right. Both of these go to 0. So we end up with this term and this term, but keep in mind we have that 3 out front. So I'm going to have, let's simplify this. Let's highlight. I'm going to have 3 times this term and then 3 times this term right here. So just so that we're all on the same page. So for this first term, I'm going to have 3 times the negative, so I'm going to have negative 3 times negative 1 to the 1/3. And then for the second term, I'm going to have 3 times 3 minus 1 is 2 to the 1/3. For this first term, negative 1 to the 1/3, that's negative 1. Negative 3 times negative 1 is just going to be 3. And then for the second one, I'm going to say 3 times the cube root of 2. And this is going to be my answer. So those are a couple examples of improper integrals with infinite discontinuities.